Hello, hello my friends, welcome to Incidental Electronic Channel. This is Uncle Misha. We have this guy back on our bench. I don't remember if I actually repaired it and shot the video, but let's just get to the chase and see what's the problem. Or I'll tell you what's the problem because I know what's the problem. Problem is, one channel does not work. Like, how this is even possible? I remember actually this CD was working completely fine. This is nothing really to write home about CD, but what's cool about it, it has a line out, and I'm not even sure. Let me check if it's optical or not. But first, before we do anything else, let's just grab some batteries and let's try to play. Oops, the wrong battery. And then need that. Let's try to play something and see what's really going on. Yeah, what's cool about it, this guy, what I like about it, first of all, it has line out. Also, it has pretty loud amplifier. So, like, not like I'm gonna kill my ears, but sometimes it's important. Yeah, I like to have an option to play it's louder than usual. So for that we're gonna have some CDs here, quite nice ones, but like let me use some Patricios YouTube licensed video audio. Alright, let's plop some CD here and play. Phones. It's playing. And here we are with only one channel playing. Okay, let's do line out. Obviously line out doesn't change when you do volume control, but still only one channel. What the hell is going on? So only one channel is playing, which is kind of insane, because I do remember this player was working. So let's take a look what possibly may go wrong, because laser works, and I don't think laser cares about left or right channel. So what may happen, there's something wrong with the amplifier. Oh yeah, something wrong with the amplifier. That could be Okay, let's put this back on. Batteries here, headphones, and maybe need them in any soon. So let's just take it open. All-time favorite screwdriver now. It's so long, actually it's nice to use it because my hand is not obstructing the view. It's actually pretty neat feature. 5 self-toppers. So obviously, like this sort of fault, definitely going to be revolved around. Okay, is it? Around some kind of amplifier. So you have to look at the capacitors. Looks like it's all clipped. Did I unscrew all of them? Yes. It's all just clips. Oh yeah, here we are. Oh shoot. Really? Okay. Did I forgot to screw it last time? Okay, so all this stuff is just falling out. Okay, it doesn't look like it has any retaining screws, so probably when you screw top to bottom, it's just gonna hold it. Okay, yeah, no problem. So here's the optical mechanism. Let me see what kind of optical pickup they use. Who knows? Maybe this can be used in some kind of player. So this is KSS331A. Good to know. I'm just curious in case, for example, you would need to use this optical pickup in some of the nice CD players. Alright, so I'm not sure. Yeah, I don't remember if I actually looked it up. This kind of opened up this thing before, but here we are. I'm curious what kind of. Ooh, there is more stuff going on here. Let me take some photos here. Okay, cool. I took some close-up shots just for the reference, and there's a whole bunch of ICs around here. So like this guy, this guy, this guy, and obviously on the back side you have a few big ones, like these two, this and that. So I believe this is the microprocessor which actually controls everything. I'm not sure what this guy do. All right, these two I believe could be a motor drive controllers. Yeah, this is my just wild guess. And the whole bunch of these I'm not really sure, so I'm gonna be running. I'm just out of curiosity. You'll find the service manual and just double check what are all of these are. Okay, I'm just really curious. So this seems like laser stuff because there is F gain and T gain and TB. I'm not sure what really that's supposed to mean. There is a few test points right here. Oops. So yeah, I was talking about this guy and this guy. So this feels like another potentiometer right here, which is not fitted. Some capacitor is not fitted, but most of the time, if E bias, this is probably another. I don't know what is this potentiometer or actually some kind of voltage regulator, which is another one right here. Yeah, pretty nice looking board, I must say, and all good capacitors, right? Yeah, Nichicon Rubicon. Yeah, Nichicon capacitors. Yeah, nice beautiful looking capacitors. And what is this nice pink one? Really hard to tell. Elna? Sanyo. So yeah, this is Sanyo. This nice capacitor is Sanyo. Cool. Okay, let me also snoop around and see and to see if there is any fault. So obviously amplifier section gonna be around here, so potentially this guy is a audio amplifier, and this is voltage regulator for audio amplifier. Yeah, because it's here is V in, right? So line output and headphone output. So clearly there is no like op amp, so this, I believe this is gonna be an amplifier for that. All right. So here's volume potentiometer, and here's all bunch of logic related to amplifier. And I think I see something. Take a look at this area. Okay, I also took a photo. Also try to zoom in as much as possible. So there is a transistor right here, and this split in the middle. Ha! So this trainee is gone. Why? The question is why? What? How this? Did they short something? Like, this is impossible. I cannot see a burned transistor from just being shorted, because even amount of energy in those two batteries could be like pretty decent. You can do 2 amps if it's short circuit. So maybe, but like how this has happened, I do not know. And another problem, I do not have such teeny tiny transistors, but clearly a transistor, right? Yeah, it's like 2 of them right beside each other, assuming this is some sort of transistor for either switching or the thing, a muting transistor would need to be here, or just little amplifiers for the audio output. Very interesting. Very interesting. So next step for me would be probably try to locate the service manual to understand what kind of transistors are these, and also try to find a donor of some sort, because I mean, I have like some Toshiba muting transistor, yeah, like which is teeny tiny but not as tiny. They rather, I don't know, good example here. They rather like this size of a transistor, like tiny bit bigger, right? This is not even transistor, it's actually a diode. This one, yeah, so wow, unbelievable. All right, let me locate the service manual. But like, why would it do that? That's bizarre. Unless it was like that from the get-go. I just did not test it well enough. Okay, I have done some investigation and also found the schematic. Our two transistors are here, and these are the guys Q101, Q201. They are muting transistors. Crazy. So yeah, so these two guys has to be replaced, and I already figured that they are 2SC4116. Let me write this down because I have another piece of service manual. 2SC4116G. So this G actually defines HFE. So yeah, so if you look at the service manual, anyways, so these transistors actually are available. But let's talk about more other things. So I was actually trying to figure out where is what here, and this is not only a piece of schematic, but the most important ICs are here. So IC 501. Do you have IC 501 on this side? No. Let's take a look on the other side. Oh man. Here C501 is a ref amp, so probably this used to amplify the signal from the laser. Then we have driver 107, I think 107 on the other side. Then we have this, what is IC302. IC302 is Bass Boost LVS headphone amplifier, which I sort of guessed correctly. So this guy is in this area responsible for the amplification. Headphone amplifier, driver, bass boost, and things like that. And automatic volume limiting something. So I see 104 is not here, so probably on the other side. But the most interesting is this IC301, which is this guy, and this guy is DA converter and low pass filter. This guy actually is a some delta, a digital to analog converter. It has analog and digital filters, and it can do 8-bit oversampling. So this I can post the spec of each individual guy, and its name is TC9404FN. So this guy is TC9404FN. So this is the essentially DAC here. So then we have servo controller, that's on the other side. So this guy BU blah blah blah, I think that's a servo controller. This OK guy is over here, is LCD driver, and essentially just a logic, controls the buttons right here and drives the LCD, and also looks like the power control, supply power to this guy. So this is essentially a main controller. And over here we have also driver 107. I mentioned that this guy is actually motor driver. It actually drives the motors. Yeah. And this one 401. What is 401? Power control. So yeah, here's the power control. Okay, so this is pretty much it. And by the magic of fast shipping from DigiKey, we got 2SC4116 GRL. So this is, I hope I guessed this correctly, because GL, as states on a service manual, there is not, this thing does not exist anymore. There is a GR right now. So, but on a, if you look at the little transistor, it actually has writing on it like this. So this is a little transistor. It has L:G. So meaning the HFE defined by this number, yeah, but by this letter. So it is G. Yeah, this little teeny tiny transistor. Something like that. So Luckily, I have found replacement, and I don't know how I'm gonna solder these teeny tiny guys, but I will try. Look at this. It's like microscopic transistor. So I happen to have these guys, alright, and they are too big. So one of them is Toshiba, this was Toshiba as well, by the way. Another is ROMs, and these Toshiba theoretically would work, or maybe ROMs as well, because they are muting transistors as well. This one is actually more like a general purpose amplification transistor, but because it has high HFE, it probably can be used as a muting transistor. Okay, so now we have to figure out how do we replace. Do we replace both of them, or replace just one and see how that... I decided to give it a try. I have several transistors, and I hope I'm not gonna mess up the board, otherwise it's just game over. Okay, so I have my soldering iron out. Okay, idea is... because this transistor is already cracked. I don't know, I'm kind of thinking maybe I should use the hot air for this. Let's add some flux in here. Where's not this one? Let's do this one. And also add some solder. It was as easy as that. Okay, so this little teeny tiny tranny is out. Now we have to use... do I have a super thin? No, I don't. This is not the thin. Oh, maybe this is thinner actually than I... the thinnest I have. Let me... I'll try to clean up as best as I could those... oh shit, I think I also pulled out the resistor. Hahaha, that's dangerous. Okay. Okay, resistors should go back. Let me take the resistor, clean this up. Okay, lightly cleaned up. Yeah, of course it's kind of asking for it. And add some solder bit. I think it's asking for SMD heat gun or okay, this is our resistor. What? It means you have to examine it because it looks like it has some kind of thingy where it's not supposed to have, unless it's just a little bit of solder sticking out. Yeah, take a look at that. And this is the transistor. Yeah, okay, so it's a little goner. Okay, we put it aside. But little teeny tiny resistor we have to examine. Okay, I increase the brightness. So I have placed, there was a bit solder, bits of solder kind of sticking out. So that resistor I think is fine. So here's the little tiny resistor. So now let me find my new transistors. So I'll try to use hot air gun and to reflow. Okay, taking the little teeny tiny trainer out of here, just like this, and putting it right here. Okay, I'll use Captain Tape. I will cover this up, all these, and I'll use a hot air gun in order to actually kind of apply hot air a little bit in this area, hoping that these guys will fall in their places. Let me try to do that. Hope I'm not gonna mess it up. Alright, I think I finally soldered this guy properly, and resistors as well. Let me just peel this off. Okay, I hope I didn't damage this potentiometer, otherwise it's just game over, because I won't be able to find that. Oh, looks like it's still spinning. Alright, so it called to the touch. Okay, so let's just give it a try. What else we can do, right? Okay, so I decided to quickly just assemble it, just for the purpose of testing. Let me see if everything is appropriately aligned, because it doesn't feel like it is. Okay, now it's better. Some buttons were not aligned, now they are. Okay, let's put the laser module back on. Takes some time. Fiddle. Okay. I'm curious if I can fire it up. Now, better just close it. It's easy to pull it back. Not gonna screw it in, just gonna latch it. Yeah, of course. Okay, let's put some batteries. More batteries around here. So okay, batteries are in. Let's see what's gonna happen if I play. Okay, at least it powers up. So it's good. No disc, obviously. Let's find my favorite Patrick CD and hit it. Okay, it plays. Headphones. No. It still plays one side only. That sucks. Okay, it didn't fix our problem. Oh, so now I have to probe, unless I did a mistake and didn't solder properly. You know, after this fiasco with replacing the muting transistor, which actually turned out to be, if I would really nicely look into schematic, has nothing to do with headphones. So muting transistor seems like is muting when you are using actually mute switch. Anyways, looks like muting transistor controlling only the line out. I guess this is to switch either for line out or yeah, I don't know why there is a muting transistor here. So and this guy controls muting. So when I guess it says mute, it mutes everything, I assume, potentially. Okay, so now we have digital analog converter. We have to check if there is a signal here. All right, on those two. Then we have to check if there's a signal here. Okay, this left out and right out. And also you would have to check signal in these inputs. So yeah, it's much more work than I anticipated, but I think just for the giggles we would do that. So now I have to kind of go forward and start probing. The only thing is, it's very hard to probe you know, for these all signals when there is a CD in there. So yeah, I'm not really sure how I'm gonna do all this. So I probably have to, yeah, I don't know, maybe run it like this, you know, without this bottom one, power it from the power supply and try to probe. So this is the only possibility. So yeah, let's take it back apart and let's try looking into what we have. Alright, my friends, look at this mess on my desk of stuff, because it took me quite a while to figure out what's going on here. I think I did figure out, and there's no point to go through and show you my process. So essentially what I was doing, I tried to measure signal right here, I tried to measure signal right here, and I measure signal right here, over here, between the DAC and the amplifier, and I noticed there is only one channel output signal. So where I was measuring it, on those capacitors. So these capacitors are bypass capacitors, which goes between DAC and the amplifier, and when I measure signal here, only one channel has signal, another is not. So I think here either we don't have data from DSP, it doesn't send proper data, which I won't be able to analyze. I'm not sure if this is I2S or whatever it is. I need to kind of figure this out. But this data is missing one channel, potentially. But that means it's not coming from the CD. Or we have issue that one channel here is busted. Or we have problem with those muting transistors right here, and they still not working as they supposed to work. So this is a possibility. The only thing what I need to figure out, if the transistor that it was busted corresponds to the channel which is not working. Yeah, because transistor was busted, because it's a muting transistor, it could be just open and has no effect on the circuit, and the other transistor which was not open could have conduct, for example, and kill the DAC. Like just hypothesis. And unfortunately, I do not remember what side, because it was very awkward to probe with oscilloscope. I don't remember what side was actually producing the signal, what's not. Which I think this side was producing the signal. Yeah. I was measuring with oscilloscope, and that means, can I trace it? Alright, my friends. Sorry, I got a little bit sick, so I'm now kind of recovering. But this mess on my desk here, and I decided to actually clear it out even when I'm a little bit sick. So I have this power supply which is 5 volt. This from Sony PlayStation turned out to be, it's perfectly compatible with this guy. This requires 4.5 volt, this 5 volt. I don't think there's going to be much of a difference, so we can use this to power our gentleman up. Also, I have created this frequency test CD, which I'll be using for testing the circuits here. My idea, let me shut it down for now. Oh, it's very tight. So my idea is, alright, so we, okay, let's turn it back on. So we know that this guy is a DAC, this is the this guy is amplifier. So I traced, I got the schematic and traced some of the connections between the DAC and amplifier, and there are these capacitors right here. Okay, these four, okay, I need to remove this as well, capacitors. So they're essentially bypass capacitors. I think 2 of them right between so essentially there are four capacitors in total. 2 capacitors, on one on left channel and on right channel. So my idea is to try probing around my frequency test CD and start probing at those capacitors to see if there is a signal. I may even desolder the capacitors actually, just to make sure that we have separately signal from the DAC, and then I'm gonna put them back, or probably put them back and check if there is a signal coming out from the Oh no, you know what? First, actually, before the soldering, try to use the CD and get if to see if actually anything coming to the amplifier with all these capacitors and things like that. It will be really hard to do because it's all really tight here, and if you have a CD spinning, it's kind of interfere, but you cannot run CD upside down. So I need to think about. And my idea is to actually solder really thin wires, which actually coming from those bypass capacitors, to be able to probe outside. So essentially, I need 4 wires. Yeah, probably 2, or at least 2 at first. Solder 2 capacitors which are right before the inputs into the amplifier, and maybe then when I desolder the 2 capacitors which are right after the outputs of the DAG, and I need 2 more pigtails actually to measure the signal what's coming out of the DAG. Okay, so this is my idea. So let me turn the soldering iron on and try to solder some little pigtails right here. Alright, so I decided to thin some bunch wires, and right now I'm soldering them to the DAG side. It turned out to be, I was wrong. Alright, so these 2 capacitors and these 2 capacitors are important for us. So these capacitors which are going to amplifier. Alright, solder some little wires here, and solder some little wires. If I'm not mistaken, right here. So in both cases, those are supposed to be positive. Okay. Looks like I connected in both cases to negatives. Alright, redo. Not like it matters, but okay, I think we're done here. So here are our connectors. Over here there is a little pad called open. So in order to operate CD without closing the lead or engaging this button, we have to short this one. If you short this one, the CD player will operate without closing the lead. So it's a test thing. There's also a little test point right here. I'm not really sure what it does. Need to figure this out. But so far, this is how we're gonna operate. We're gonna use oscilloscope, and we're gonna probe over here. Ground will be using this guy, negative. Actually, I am wrong. If I'm gonna power it with this guy, I have to actually solder negative straight to here, because this negative will be disconnected. Alright, I also soldered the ground just for ease to access. Okay, so let's take our frequency test CD and fire it up. Also, I decided to glue with tape CD mechanism in place because it was all over the shop. Let me see if it produces any sound. Alright, so we have a signal. Barely hear it, but there is a signal. Then probably maybe volume. This is actually max volume. Haha. So probably digital file I have to increase the volume, but for the sake of oscilloscope should be fine. Let me actually see what we have in should be like 100 Hz or something. Don't remember, but so I decided to use oscilloscope, and that's what I have. So I have a signal of 1 kHz. That's correct. Let's try it on another channel. And I have signal of 1 kHz as well. Now we have jumped 3 kilohertz, and it is showing. So that's interesting. I measured nothing. Yeah, it's very hard to show you. Let me. Yep, this is 3 kilohertz, and clearly it's on both channels of the DAC. Yeah, that's bizarre. Let me disconnect speakers. Okay, clearly there is it's attenuated, but there is a signal here. How about this? Yeah, it's pretty bad on this side. Wow. I'm curious what's going on here. Look at this. It's much higher amplitude here. But this actually disproves that our DAC is operational. So what could have happened? When you have... Okay, this is not 250 kilohertz, of course. So this is 400 hertz signal. Okay, Okay, let's go forward. Should be 1 kilohertz. Yeah, the other channel is like bad. Wow. So the main thing with our DACs is actually outputs the necessary signals. So I'm curious where it's getting busted. Alright, so I decided to take a look at those transistors again. So looks like the channel which is not working, and it's this one. This is C107, which is connected to Q101, which is this guy, and it is gray and it is left channel. So and that's correct. And this one we replaced. So there is clearly something wrong in this area. So what we're gonna do, we're gonna pull this thing out. Unfortunately, we'll try to do this somehow. I don't even know how. Probably the best way of doing it, it's hot air, but I hate this hot air thingy. So I'll try to do it with just soldering iron. Yeah, we removed the transistor. That was quick actually. This is why I like this low temperature melt solder. Okay, then we figure out what to do. Oops. These are our teeny tiny transistors. We're gonna put it in here. Right, in here. Okay, so out of muting transistor. And let's see what's gonna happen. There is no muting transistor, nothing to load this thing down. If there is a problem. What's happening? Ah, pressing the wrong button. Alright, let's do our frequency thingy. Forward, forward, forward. Track number 4. Let's connect the oscilloscope to the gray channel now. And we still don't have signal. That sucks. So nothing to do with muting. Damn, you oscilloscope, can you stay? That's bizarre because this is, unless amplifier itself is loading it, otherwise I can nothing. Also I checked the capacitor, so C107 is actually good, so I checked it. It's not, you know. Alright, we took off this little tiny capacitor, soldered the wire on the DAC side, not on the amp side. Alright, let's just nicely turn all this, yeah, around. Connect. And play. And here we are. We have a signal on one side. I don't know what to say. Does it really means that actually the amplifier is Gonski? Well, I think at this point I can claim that probably our BA chip, which is audio amplifier, is not good. The only last thing I would like to try is to use multimeter and to measure the resistance, input resistance of that chip. So let's see how we can do that. So we have this, okay, versus the ground first. Let's see. Okay, so we're gonna use that parts of the capacitor. So we have 45 kilo ohm, 45 kilo ohm. That's pretty much the same. Okay, let's change the resistance of the volume potentiometer. 41 kilo ohm and 41 kilo. I do not understand. I thought because it's going to be pulling down the line, it won't be working, but it seems to be okay. So let me check this capacitor then. I don't know what else to do. Just before I completely, you know, claim that the amplifier is gone. One more time. 4 ohm. Yeah, this seems to be all right. And 4.7, 1 microfarad, 50 volt. 1 microfarad we can measure. Let's see if this is correct. But that's bypass capacitor. I don't think it's a. 1 microfarad. Okay, correct. So capacitors is fine. Yeah, volume potentiometer seems to be alright, so I'm not sure what else I can do here. So probably the input of the amplifier is gone, because there is nothing else there. So yeah, there is only potentiometer and then there is an amplifier. That's it. So probably we're gonna stop that. We're gonna unsolder all these wires, make a note and glue it to the player. Yeah. Another option is to unsolder the second capacitor and use just the line out to have them at the same level. It's an option. Okay, I'm probably gonna do that. So unsoldering all these leads. Soldering second capacitor. I hate when they bend through whole component sleeves. Hate that big times. Where is that? Oh, this guy. Here we are. Okay. So now our line out will be identical on both channels, and we can use it at least with the line out. I think that's gonna be pretty much it with this with troubleshooting of this CD player. I think it's a nice CD player, nice mechanism, and theoretically if I find something broken I can just use this for parts, but at least it's gonna work for line out. Sorry for messy troubleshooting and repair. I'm still kind of thick recovering, but I really wanted to finish this up. So guys, please stay tuned for more videos, and please subscribe, like, comment. Be happy to hear from you. Stay safe and ciao, and stay healthy. Take care.